Hello and welcome, I'm your Code Monkey. In this lecture we're going to handle the game over state. Now for the game over state, this is obviously a game design question. For example, you could make it so that each recipe had a timer attached to it and the player had to create that recipe within the time limit. Then if they failed enough recipes, you could trigger some kind of game over. Or for something more simple, let's just do exactly what we did for the game start. Let's just do a basic countdown timer. After the game is over, let's pop up a game over window and show how many recipes the player delivered. So let's do that. Let's go into our canvas and inside make an empty game object, call it the game over UI. Then over here, let's stretch it to occupy the entire parent, like this. Now inside, let's begin by making a UI image. This is going to be the background. Let's put it in black with just a little bit of transparency. And let's also stretch this to occupy the entire thing. So just like this. Then let's make some text, so let's make a new UI text, call it the game over text, and let's say just game over. Let's set the width and height both at 0, then down here, disable wrapping, put it centered. Let's put it pretty big, so maybe 135, put it a little bit higher. Then for some more text, let's duplicate this. Let's call this the label recipes delivered text. And over here we just say recipes delivered. Let's put this one a bit lower and quite a bit smaller, say on 50. Okay, and also on this one, let's put it in bold and change the color a little bit. Okay, next let's make yet another text. This one is going to be for the final number, so let's call this recipes delivered text. And this one is just going to have whatever number of recipes we delivered, and let's put it over here and quite a bit bigger. Okay, so this is the game over window that we want. Also, quick note, like I mentioned previously, the sorting order over here on the UI is based on the order in the hierarchy. So for the game over, we want this one to show up on top of everything else. So make sure the game over is the last one over here on the UI. Make sure it is the bottommost child on the canvas. Okay, now let's make a game object to run this. So let's create a brand new script. Game over UI, let's go into the object, wait for the compilation, and let's drag the script. Okay. Now here, the only reference that we need is just for the text, so let's just make a serialized field of type text mesh pro UGUI for the recipes delivered text. Here in the editor, let's just drag that reference, okay? Now let's make some show and hide functions and also show it just on the game over. So really, we're going to do the exact same thing that we did over here on the game start countdown. So let's actually copy exactly this. Let's go into game over UI, pass the exact same thing. Okay, so we've got the show and hide functions, we test, and then over here on the state change, instead of showing this one on the countdown, we want to show it on the game over. So let's go over here and just make another function. So public bool is game over, and we just return if the state equals the state.gameOver. Okay, that's the function. So over here, if we are is state game over, if so, then we show, if not, we hide. Okay, the last thing we need is just for the text. So this is going to be the recipes delivered text. So we're going to set this to something, which really means that we just need to keep track of all of the recipes that have been delivered. So let's go here onto the delivery manager script and let's just keep track. So just a simple int, so a private int for the successful recipes amount. And then whenever we have a recipe success, so let's go here into our delivery recipe function. Whenever we have a success, let's just increase this by 1. Okay, so that's it. Now we just need a function to expose this. So a public int for the get the successful recipes amount and just return the successful recipes amount. Okay, so finally back here on the game over UI, let's just print it. So go into delivery manager, access the static instance and get the successful recipes amount. And of course we need a string, so toString. Except for this one, this is never going to change after the game's already over. So let's not do this on update. That would be quite wasteful. So let's just do it up here. So as soon as we have the game over, we print the recipes, and that's it. Okay, so let's test. So here we are waiting for the timer. And let's wait and just wait 5 seconds for it to finish. And we should see a 0. So let's just make sure that works. So after a little bit of time, yep, there you go. We've got recipes delivered 0. Okay. Now back here again, let's try to deliver some recipes now. So let's try to make a cheeseburger. Try to deliver that. Cut this one, pick up this one, pick it up, put it in there. And okay, quickly. All right, good. And there you go, we've got a 1. All right, awesome. Everything worked perfectly. Let's just add one more final element. Right now we cannot see what is the time left in the game, so let's add a nice clock element. So over here on the canvas, let's make another empty game object. Let's name this the game playing clock UI. And let's also put it behind the game over UI. So let's put it above on the hierarchy so that it shows up behind. In order to be able to see what we're doing, let's also just hide the game over UI, but only here on scene view. So let's click on the eye icon. Okay, so here we have our window. Let's just anchor it on the upper right corner. So let's put it somewhere in there. Then inside, let's create a new UI image. Call it the background. For the sprite, let's go with the circle sprite. So let's click on the eye icon to show all the default sprites, and let's use the one included with the circle. So you have this one. Let's also add a nice little outline. So let's put it on 2.2 with full alpha, and let's also add a nice shadow, just a nice visual. So on 5-5 like that. And for the color, let's also put it some kind of dark gray. Okay, so this is our background. Now let's duplicate this. So Control D. And let's rename this one the timer image. And for this one, let's give it a different color. So maybe something like a blue. So something like this, okay. And now over here on the image type, instead of simple, let's go with filled. Let's choose radial 360, okay, great. And now over here we can play around with the fill amount, and this will be our timer. Then you can set it up however you want. For me, I'm going to choose to start from the top. So as it starts, the timer is going to count down until the end. Okay, so that's great. Now let's make the script to run this. So let's create a brand new C# script. Same thing, the game playing clock UI. And over here, let's just attach a script. So now all we need is reference to our image. So let's make a serialized field. Private image. Let's make sure to use this one, the image inside Unity Engine.ui. This is going to be our timer image. Okay, like this. Back here in the editor, let's drag the reference, all right. Now that we have this, we need to ask the game manager to get the timer normalized. So let's go over here onto the kitchen game manager and let's make a function to return just that. So a public float, let's call it get playing timer normalized, or game playing timer, actually, just to match the state. So get this one, and up here we have the playing timer. We just need to define a maximum in order to be able to calculate the normalized value. So let's duplicate this, call it the game timer max, and set this one to 10, and this one, leave it like this. And down here, when we change the timer, when we go into game playing, let's set this one equals this.max. That way we only define the timer just up here. Okay, so with that, now down here we can do the compilation. So we can return the game playing timer divided by the game playing timer max. Except just like this is going to be inverted, because for the game playing timer, we're counting down instead of counting up. So all we need to do is very simple, just reverse this. So just 1 minus, just like this. Okay, great. So we have this function. And then over here on the clock, just go private void update. And on update, let's go into the kitchen game manager, the instance. Let's get that. And we're going to use that on the timer image.fillAmount. Okay, that's it. Super simple. Let's see. Okay, here we are on the waiting to start. All right, waiting. And as soon as we start, yep, there you go. There's the timer going. And we can see it constantly increasing. So it's at the halfway point. And just a little bit more. And there you go. Yep, we've got the time over and we have our game over. All right, awesome. So over here, we implemented a really nice game over state. We have a playing timer with a nice UI element, and when it ends, we get a game over window showing a bunch of stats. Now with this working, the next task is to have some kind of main menu so we can play again after the game is done. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to make a super simple main menu and a loading system. Okay, so every game needs a main menu, so let's build one. Let's begin by making the scene, so let's go into our scenes and create a brand new scene. Call this the main menu scene. And okay, here's our default scene. Now over here, for the most part, we really just want some basic buttons, so nothing too special. So let's create a brand new UI canvas. And let's set it up as usual, so screen space overlay, yep. Then let's go with scale with screen size. 1920 by 1080, and let's match with the height. Okay, so there's our canvas. Now inside, let's make an empty game object, name this the main menu UI. Let's stretch it to occupy the entire thing, so 0, 0 on everything, okay. Now inside, let's create a brand new UI button. Let's name this the play button. Then inside for the text, let's say play. Let's size the button to be quite a bit bigger, so let's say 450 by 150. And on the text itself, let's put it in bold, on a font size quite a bit bigger, let's say 70. Then let's also change the color. Let's put the text in white and the play button over here, the normal color for the image. Let's put it on a dark gray. Then also over here on the button background, let's add a nice outline. Let's put it on full black, say something like 3:3. Then let's make a shadow. And for this one, 5 - 5. Okay, so that's our basic button. Let's just anchor the button. So choose the play button. Let's anchor it on the lower left corner. And let's push it just a bit like this. Okay, pretty simple. Now let's duplicate this one, push it a bit lower. Let's also make it just a tiny bit smaller, so just 120. This is going to be our quit button, so let's rename this to the quit button. And inside for the text, just say quit and put a bit lower on the font size. Okay, like this. Okay, so we have the two basic buttons that we need. Now let's make the script to run them. So let's make a script with the same name, so main menu UI. So let's go into our script UI folder, create new script for the main menu UI. Let's attach the script and open. Okay, so now here let's begin by making serialized fields for our buttons. So a serialized field, private of type button inside Unity engine.ui. This is the play button, and then we have another one for the quit button, okay? Back in the editor, let's drag the references, so that's the play button and the quit button, okay? Now here in the code, let's add some listeners to these buttons, so let's do a private void awake, and on awake, let's go into the play button, and go into the on-click event, so the event when the player clicks on the button, and let's add a listener, and now we pass in the listener. Now over here, to do this, we can add a function, so we can make a private void play click. We can define a function kind of like this, and over here add it as a listener. So that's one approach. Or another alternative that personally I like to use is to use what is called a lambda expression. So instead of defining an external function down here, we just go up here and directly we define a lambda. So we open parameters to display the parameters for the function, which in this case we have none, so just open and close. Then we do a nice little arrow, and then we have whatever we want to be our click code. So both the code that I have here and the one that I have here, both of these are exactly the same thing. This one is called a lambda expression, which is also a type of delegate. Definitely go ahead and watch my video on C# delegates in detail. It's yet another extremely powerful C# feature. I find them especially useful, especially over here to setting the click listeners. There's no need to make another function, just use a lambda expression and that's it. So over here I'm going to use that instead of an external function. Okay, so we've got the play, and then let's also listen to the quit. So on the quit button, the exact same thing. Okay, now first on the quit button, it's actually very simple. We just go into application and we call the quit function. This will quit the game, that's it, very simple. Although one note, if we actually test it like this, so here is the game playing, and if I click on quit, and nope, nothing happens. Now the logic is actually working. We can see visually that the button is changing state, so we are indeed capturing clicks. However, when the game is running inside the editor, calling that function, the application.quit, doesn't do anything. But if this were a full build, then clicking on that would indeed close our game. Okay, so now for the play button. For this one, it's also very simple. We just need to go inside the scene manager, which is inside Unity engine.scene management. We just need to go inside of this one, and we call load scene. This function will load a certain scene, and for loading, we can either use the scene build index, or we can use the scene name. Like I've mentioned several times, string names are horrible, although in this case the alternative using an int is also not very good. Just a number is very hard to read the code and be able to know what scene this is loading. So there's one better approach that I prefer to use, but first over here let's just use the index just for testing. So we're going to load the scene on index 1, so just like this. And then here in the editor, let's go into File and Build Settings. And over here we see the scenes in our build. Right now we just have the game scene. So let's just add our scene. So let's drag the main menu scene and drag it on there. And also let's make sure it's on the top of the list. Basically the first scene is the one that won't be loaded as soon as the game starts. So let's drag it right up top, just like that. Then over here on the right, we see the index. So by loading the scene on index 1, we're going to be loading the game scene. Okay, so with this, let's test. So here we are, and if I click on play, and if there you go, it does load the main scene. Okay, great, everything is working. So this is the simplest way to do scene loading. However, this method does have one issue. It's not super noticeable in a game of this scale because it loads pretty quickly. But like this, note how when we click on play, there you go, everything freezes for a little bit while the game is loading. Like I mentioned, in this case the freeze is so small, so not necessarily an issue. But if the game was much more complex, then the player would be staring at a frozen main menu for perhaps 30 seconds. That would not be good. One way to avoid that is actually very simple. Basically, it's what I already covered in detail in the scene loading video. That video was made quite a while ago, but it's still very much up to date. Here we're going to do pretty much the same thing. So we first create the scene, just empty, just saying loading, and then from that scene, we load the final scene. That way the game stays frozen on a scene that says loading, which is much more clear to the player. So let's do that. First, let's make our scene. So inside our scenes folder, let's create a brand new scene. Call this the loading scene. Okay, let's go inside. And now in this one, we want this one to be fully black. So let's go into the main camera and scroll down over here under environment. And instead of rendering the skybox, for the background, let's go with a solid color and let's go with full black. Okay, there's our black main camera. Now let's make a canvas. So a new UI canvas. Let's set it up as usual. So scale with screen size, 1920 by 1080 and match with the height. Okay. Then inside, let's just make a simple text object. So just say text, then over here, let's say just loading. Let's put the text width and height on 0, put it on bold. Let's make sure to disable wrapping and push it over there on the side and maybe increase the font size by a little bit. Okay, there you go. We have our very basic loading screen. Now we're going to load this scene, and then whilst on this scene, we're going to load the final scene. Although also one very important thing related to loading scenes is you need to remember the lifetime of the objects. Regular game objects, like for example the ones that we see here in the hierarchy, these get destroyed when you do a scene change. So for the goal that we're trying to achieve, we need to load this loading scene, but then also somehow transfer data so that the loading scene here knows which one is the final scene. Now you might think that over here on the main menu we could create a game object, attach a script that would hold the reference to the final scene, but like I said, game objects get destroyed as soon as we load the loading scene. So for transferring data between scenes, we can't really use a regular script on a regular game object. Now one approach is to use the don't destroy on load. This is a Unity function that helps you stop a particular script or a game object from being destroyed. That way the object won't persist through scene changes, so that's one option. But another option that I prefer is very simple. Let's just make a loader class. So let's create a new C# script, call this loader. And over here, let's go ahead and make this class a static class, and we are not going to extend model behavior. So just like this. Basically, by making it static, it means that this one is not attached to any specific instance of an object. This class cannot be attached to any object and cannot have any instances constructed. Then inside, we can add static functions in fields, like for example, a static int for the target scene index. So now this field, we could set this field from over here on the main menu UI. And when we would load, we would not be resetting this field. Also here, I should point out one quick thing. You can make fields static without making the entire class itself static. Making the class static is just a good approach if the entire thing, if everything in this class is also meant to be static. If you don't make it static, then you can have regular fields here. You can have both static and non-static. Whereas if you make this static, then you're going to have an error because you cannot have non-static fields. So this is another clean code thing. If it's only meant to contain static logic, then make the class itself static. Okay, so we have a static field for our target scene. But as usual, we don't want this to be a public field. We don't want the main menu to directly write to this field. So let's make this class the only one responsible for anything related with scene loading. So instead, let's make a function. So a public static void, call it load. And for a parameter, let's receive a string for the target scene name. Then over here, we load the actual scene. So let's go into the scene manager and load the scene. And let's pass in the target scene name. Okay, that's it. And then over here on the main menu UI, instead of directly loading a scene, let's go into the loader and call load and pass in the scene name. So that's the game scene. Okay, so this is what we're going to do. That's good. Except it's obviously not good. Over here, we're using string names. That's horrible. We should never use this. So let's avoid using strings as much as possible, and one simple way is to just define an enum for all of our scenes. So let's go here on the loader and let's define that. So a public enum, let's call it scene. And for all of our scenes, so we have the main menu scene, then we have the game scene and the loading scene. Okay, so then down here on this function, instead of receiving a string, we just receive a scene for the target scene, and we use the target scene. Although, of course, the Unity API does not support loading our custom enum, it has to be an index or a string. So the simple approach is just to convert this one into a string. That's it. So the only thing you need to make sure is that the enum values over here match the actual name on the actual scenes perfectly. So don't make any mistakes. Keep it case sensitive, so don't do this. Make sure everything matches perfectly. Okay, so just like this, everything should already be working the same as previously. So the main menu calls that. Let's actually just use that. So let's use scene.gameScene. So on the main menu, we do this, and on the loader, we load the scene. Okay, let's test. Here is the main menu, and if we click and wait a bit, and yep, there you go, it didn't load the game scene. Okay, great. So everything still works the same as previously, except now all of the unloading logic is inside of this class. And over here, let's load a loading scene in the middle. Basically, when we have this function to load a final scene, let's first off set this field. So this one, instead of being type int, let's make it of type scene, and this is going to be the target scene, and let's make it private, okay? So when we have this function, let's set that field. Although here, remember how this is a static class, so in order to access this field, we need to access it through the class name, because over here we also have a local variable with the exact same name. So let's access the unloader.targetScene and set it to the target scene. So again, don't be confused here. You can even use Visual Studio and put the cursor on top to see what object represents what. So you can see the unloader.targetScene is referencing this field, whereas this one over here is referencing the local field. So we want to assign the member field to the one that we received as a parameter. Okay, so we store that, and then let's immediately load the loading scene. So scene manager, let's load the scene, and we're going to load the scene.loadingScene.toString. Okay, so we're going to load that. And now here comes the tricky part. If we do this, so if we load the loading scene and then immediately load the target scene, if we do it like this, it won't actually show the loading scene. We're calling these functions one right after the other, so it will load one and immediately the other. Basically, we need to wait at least one frame to render so that the unloading scene is visible, and then we can load the final scene. So let's make a script to do a very simple job. Let's create a brand new C# script for the unloader callback. And now let's go inside the unloading scene. So this is important. Let's make this on the loading scene, not the main menu or the game scene. So over here, let's create an empty game object for the unloader callback. Let's reset transform, just keep things nice and clean. And let's attach the script, so the unloader callback, okay? And on this script, we want to basically just wait for the very first update. So let's do a private bool is first update, and we start it off as true actually. So is the first update is true, then we do a private void update. So if it is the first update, if so, then let's set is first update to false. And we have the first update. Although technically I should point out that we don't really need this. We're going to load right away, so either way it will only run one update, but still I like to add this just to make the logic perfectly clear. Basically, if it is the first update, then let's call a function on the unloader. So on the loader over here, let's make a function, public static void, call it loader callback. Okay, we have this function. So over here on the unloader callback, let's just go into the unloader and call the unloader callback function, all right? So basically now here we have this function that is going to be triggered on the first update. So we know for certain the unloading scene has been rendered. So it's over here that we want to load the actual final scene. Okay, that's it. Here we have a super simple loading system. Just make perfectly sure that the unloader callback with the script, this one only exists on the loading scene. It should not be on any of the other ones. So let's test, and for that, let's go inside the main menu scene. Okay, and now let's hit on play. Okay, so here we are on the main menu. Now if I click on play, and actually here's the thing that I forgot, so make sure you don't forget this. We need to add the unloading scene to the builds in order to be able to load. So let's go up here into the build settings. Let's go into the project, drag the unloading scene like that. Okay, so now let's test. So here we are on the main menu. Let's hit on play, and there's the loading scene. After a bit, yep, here we have our game scene. All right, awesome. So with that, everything is working perfectly. All of the logic is working great. Now that it all works great, let's just make a nice proper visual for our main menu. So for that, let's go inside the game scene, and over here, let's copy a few things. So let's pick up the floor object, and let's also pick up the global volume with the post-processing. So let's copy both of these. Let's go into the main menu scene, and over here, let's paste both objects, okay? Now let's also drag some player visuals. So let's put this in 3D, go back down into the floor, and let's pick up some visuals. So let's go inside our assets on the prefabs visuals. Let's find over here the player visual. Again, make sure you drag the visual only. We don't want any logic components. And by the way, this is yet another great benefit of separating the logic from the visuals. Right now, it's super simple for us to place some players here because we have just the visuals completely separated from the logic. Okay, so on the visual, let's just make it look at the camera. Let's position a bunch more players. So let's duplicate this and put one to the side. We're going to move the camera in a bit, but now let's just place them. And in included assets, there are a bunch of materials. So over here we see the player body, then we've got a blue, a green, and a red. Like I said, this first course is on making this game in single player, but the goal is to then make a second course after this one on converting this game into multiplayer, so that's why I included multiple colors. So let's just drag these. Let's go into this player visual, and on this one, make it blue. So on the head and on the body. Then on this one on the side here, let's make this one green. So green there and green on the head. And for the one behind, let's make this one the red one. So put it in red and in red. Okay, so we've got our nice 4 players. Now let's also add a camera. So we're going to have the camera kind of like this, kind of from below looking upwards. I think that looks pretty good. For that, let's use Cinemachine. So let's go into Game Object, go into Cinemachine, and let's create a brand new virtual camera. Okay, like this. Let's just push it up a little bit. Okay, so this is our nice composition. Now on the virtual camera, let's just go ahead and add some noise. So let's add basic multi-channel purlin. So let's do it just like we did when we first added Cinemachine. So let's use the handheld normal mild. And now let's just play around these fields, which by the way, you can do that while the game is playing. So let's hit on play. And over here, you can play around all the fields. Although actually defaults already look pretty good, but let's put the frequency maybe a little bit less and the amplitude maybe a little bit bigger. So just some nice little sway. And by the way, if you make any changes to the Cinemachine virtual camera, and if now you stop playing, it will actually lose those changes. But over here on the virtual camera, there's this nice toggle, save during play. So if you tick this, and now you exit play mode, and there you go, those changes were saved. Okay, great. Now let's just make sure to untick this so we don't accidentally modify. Okay, so here we have the basic visual that we want. Finally, there's also a game logo in the included assets. So let's just go into our canvas, into our main menu. Let's create a brand new UI image. Let's assign the logo sprite. Then let's just position it on that corner. So let's move it all the way up there. We can anchor it to the top left corner. And let's make it a bit bigger. And by the way, on something like this, if you play around this, it might get a bit stretched. So if so, over here on the options on the image, you can toggle this one to preserve the aspect ratio. So that way, even if you stretch, it won't actually be stretched. It will always be perfect. Okay, just like this. Okay, so here we have our basic main menu. It's a basic setup, but it looks pretty good. And with that, we have built a nice main menu alongside with a loading system. So I can click on play, it goes into the loading scene and then into the game scene, so that's great. The next thing that we need is some kind of pause button, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add a pause button with a pause window that also has the ability to quit back to the main menu, and in doing so, we're also going to solve some sneaky issues with loading. Okay, so here in the main menu, we can click the play button in order to load the game, and yep, everything works, now I'm in the game. But now let's say I want to pause the game for a bit, or quit back to the main menu. Right now there's no way, so let's do that. Let's go here onto the game scene, and first let's handle the pause, and for that we're actually going to need some input. So let's first go inside our player input actions, let's open this, and then over here let's make a brand new action. Let's name it the pause. For the action type, let's go with button, okay, and for the bindings, over here let's go with escape. And actually, if we use the same method that we've been using, if we listen and press on escape, nope, doesn't work because escape just cancels it. So instead we need to use the search bar here, search for escape keyboard, just like this. Okay, great. Now again, as always, let's make sure to save the asset and wait for the compilation to happen. There it is. So now here on the game input class, let's listen to it and fire the event as usual. So go into the player input actions, the player action map. Let's go into the pause action and listen to the performed event. And when this happens, let's fire off an event. So a public event handler. Let's go on pause action. And then down here, we're simply going to invoke this event. Okay, just like this. Now for listening to it, here's the question, where does that make more sense? Should we do it over here on the player script or perhaps over here on the kitchen game manager? I think over here on the game manager makes more sense since a pause is more related to the game itself rather than a specific action by the player. So let's add it over here. Let's first of all listen to the event. So let's do a private void start, and on start, let's listen to it. So let's go into the game input, and we didn't actually make it a singleton yet, so let's do that. Over here, let's make a public static game input for the instance with a public get and a private set. Then down here on awake, let's set instance equals this. Okay, there's our singleton. So now back in the kitchen game manager, let's go into the instance and listen to the on pause action event. And again, let's rename this to give it a proper name. So this is the game input on pause action. Okay, so here we have it. When we have this, let's call some kind of pause game function. So let's define this. Let's go to the end of the file here. And over here, let's make that function. So a private void, pause game, and over here, we're going to pause the game. Now for pausing, doing this is actually surprisingly easy. Basically, all of our logic is using time.time. For example, over here on the player script, we have our movement speed. Yep, then we get the inputs. And over here on the handle movement function, yep, for the movement distance, we have move speed multiplied by time.time. Or another use case over here on the stove counter, we've got a frying timer, and how we count it down, again, is the same thing, time.time. Well, it turns out that behind the scenes, time.time actually already has a multiplier. When you access this, it is after that multiplier calculation. So over here on the pause game function, we can just go into time, and we can modify the time scale. This one is the multiplier. So if we just put this at 0f, then that's it. This is going to pause all of the other delta times. So let's test. So here we are, pay attention to that and the countdown timer, and I press on escape, and there you go, everything pauses. The countdown timer pauses, over here the script pauses, and I can no longer move, nothing works, everything is perfectly paused. Alright, awesome, everything works. Except one problem, obviously right now we cannot unpause. If I press escape, it's not unpausing, so let's do that. Over here on the kitchen game manager, let's add a simple bool, so a private bool. Let's call it isGamePaused, and let's default it to false. Okay, so isGamePaused. And then down here on the pause game function, let's simply flip this one. So we set this one equals not this one, so that is going to flip that boolean. And then we check if the game is paused. If so, set it to 0f. And if not, then we're going to set the time.time scale back into 1f. Okay, so now this should pause and unpause. So let's actually rename this function, since this is no longer just going to pause. Let's rename this to toggle pause game. This is going to pause and unpause. Okay, so let's test. Okay, so here we are, everything is running. Now I pause, and there you go, everything freezes. I cannot move, the arrow is stopped, the countdown is stopped. Now I press again, and there you go, nice and resumed. All right, great. So all of the logic is working perfectly. The only thing we need is really just a visual. And as usual, let's separate the logic from the visuals. So let's go inside the canvas, let's go into the scene view. And inside the canvas, let's create an empty game object, call it the game pause UI. Then let's stretch to occupy the entire screen, so 0 on everything. Okay, great. Now inside, let's first of all add a background. So a new image, name this the background. Let's once again stretch to occupy everything. And on the color, let's put it in black with just a little bit of alpha. Okay, just like that. Then let's add some text. So let's create a brand new UI text. Let's name it pause text. And in here, let's just say paused. Let's just make it big, so the width and height both on 0. Let's disable wrapping, put it center down the middle, and let's increase the font size by quite a bit and put it in bold. And let's also change the color, maybe a nice yellow, something like this. Okay, that looks pretty good. Let's just lift it up by a little bit. Now let's make a script to show this. So on the UI folder, let's create a brand new C# script. Call this the game pause UI. Let's attach it and open. Now here, let's do the usual thing. So let's make two show and hide functions. So a private void show, and then a private void hide. So on the show, game object set active into true, and on the hide, set it into false. Okay, that's it, pretty simple. Now we need to know when to show or hide these functions. So over here on the kitchen game manager, let's make two events to do that. So let's go up here, make a public event, event handler. And let's name this on game paused, and another one for on game unpaused. Okay, we have both events. Then down here on the toggle pause game, if we have this one timescale 0, that means we have pause. So let's invoke the on game pause. This event tars.empty, okay. And on this one, let's trigger the other one. So on game unpaused. Okay, we've got the two basic events. Now back here on the game pause UI, let's listen to it. And as usual, let's do it on start. So private void start. Let's go into the kitchen game manager, access the static instance, and let's listen to the on game paused. And then going to listen to the other one. So the instance on game unpaused. So listen to both of them. And as usual, let's write good clean code. So let's rename this. So kitchen game manager. And on this one, the same thing. So also the kitchen game manager. Okay, we have both. And when the game is unpaused, then we want to hide the pause window. And when the game is paused, then we want to show the pause window. And finally, of course, we want to hide it by default. So over here on start, after we add listeners, let's just hide it. Okay, so that's it. That should work. So let's test. So here we are. Everything is running. Now press the pause. And there you go. Got a nice paused window. Press again. And there you go. Everything resumes. Okay, great. So the last thing that we want is just a button over here to go back to the main menu. And let's also add a button to resume without having to press the hotkey. So over here, let's create a new UI. Let's make it a button. This is going to be the main menu button. Now let's make it quite a bit bigger. Okay, width and height of 30 and 80. Let's put this one quite a bit down there. And inside for the text, this one is the main menu. Let's put the color in white and the background for the button. Let's put this one in a dark gray. And let's also, just for fun, add a nice outline. And let's also add a shadow. For the outline, let's put it on full alpha. And let's put it on about 3.3. And for the effect on the shadow, 5 minus 5. Okay, so that adds a nice outline and a nice shadow. And then for the text itself, let's put it in bold and raise it by just a little bit. Okay, just like that, looks pretty good. So this is the main menu button. And then let's also duplicate this. Let's make this one, rename it. This is the resume button. And inside on the text, let's say resume. Okay, we have our two basic buttons. So let's handle them in the script. So over here, let's add, as usual, a serialized field, private of type button. So that's inside unityengine.ui. So it's for the resume button. And then we're going to have the main menu button. Okay, let's save the script. And back in the editor, let's drag those references. So that's the main menu button and the resume button. Okay. So now for these, let's add the click action. So let's do a private void awake, and on awake, go into the resume button, the on click, and let's add a listener. So this is going to be our listener. And same thing for a main menu button. So main menu. Now for the main menu, this one is super simple. Let's just go into the loader and call the load function. And we're going to load the main menu scene. Okay, that's the main menu, very simple. And for the resume, this one is only going to be clickable when the game is paused. So we can just trigger the same function on the Kitchen Game Manager to toggle the pause. So Kitchen Game Manager, the instance, and toggle the pause game. This one is actually private, so let's go to it. And let's make this public so we can call it from there. Okay, that's it, super simple, let's test. Okay, so here we are, and let's pause the game. And now if I click on resume, yep, there you go, it does work, everything resumes. And now pause again, and now let's go back to the main menu. Loading, and yep, there you go, back in the main menu. All right, awesome. So everything works perfectly. However, there's one sneaky issue here. You can already see the issue by seeing that all of these animations are still, but let's click on play. And nope, look at that issue, everything is still frozen. I cannot move the character, and over there, the shader, that one is completely frozen. So the timescale is still set to 0. Basically, we need to manually reset it. And the simplest way to do this is really just in the main menu. So we can go here on the main menu UI, and we can just use this as our reset function. So let's just go into time.timescale, and let's set this one back into 1F. That's it, that's the only change, let's test. So here we are, let's pause, let's go back into the main menu, and we can see the animations are indeed playing, and if we go back into play, and if there you go, everything works perfectly, we can pause. And yep, here we do see one of the other two sneaky issues left. Basically, it has to do with scene loading and cleanup. So the first one is on input. Over here on the game input class, we are constructing our player input actions, and we are listening to these events. And technically, this object, the one where the game input is attached, this object is going to be destroyed when the scene changes. However, this object that we're creating, this instance of player input actions, this one does not get destroyed automatically. So that is why when I went into the pause menu again for the second time, over here we've got a missing reference exception. Basically, the player input actions of the previous game is trying to show the pause window also of the previous game, which has since been destroyed. So obviously we have a missing reference exception because that object no longer exists. So in this case, we have two options to solve this. One option is we can just unsubscribe to these events. Unity mono behaviors have a really nice callback called onDestroy. So over here, private void onDestroy. So this is the default one. This one is called when the mono behavior is destroyed. So we can go into this one and we can manually unsubscribe. And the way that you unsubscribe is you just do minus equals. So this would solve that problem because when this object is destroyed, it's going to unsubscribe from those events. So the next time it will no longer trigger. So that would fix it. However, on the game input class, we are still creating a new object of this type. I'm not 100% sure how the input system works in the background, so perhaps this object might stay in memory, which is not good. So another approach we can do, or perhaps in combination with this, is we can unsubscribe and then we can properly dispose of this object. How we do that is very simple. Let's just go into the player input actions and we just call the dispose function. That's it. This should clean up that object and free up any memory. So let's test. So here in the game view, let's pause, let's go back into the main menu. Now let's go back into the main game, and now if I hit pause, and if there you go, we no longer have any errors. Okay, so that's good. However, now we still have one more potential issue, and this one has to do with statics. Like I mentioned before, statics belong to the class and not any instance of that class, so that means that static fields will not be destroyed or reset when the scene changes. In the case of our loader here, where we have a private static field, this one, the fact that this one doesn't reset automatically, that was a good thing. That's what allowed us to make the unloading system. But in the case of maybe static events, that might not be as good. It might mean that we might be keeping some state from the previous game, which might cause everything to break. So basically we have a similar problem to what we had in the input, where some logic from the previous game might be affecting the next game. In all the code that we wrote, the main place where we used statics were in the singletons, and these are going to be cleared automatically when the underlying instance object when that one is destroyed, so these do not cause any problems. However, for example over here on the cutting counter, we've got a static event. When the scene changes, this will not be cleared, so this will still have the same number of listeners. We can actually see how many listeners there are by printing it, so let's go down here before we're invoking the event. Let's do a debug.log, let's go inside the onAnyCut event, and over here we can get the invocation list. This one is a list of all of the functions that are listening to this event. And we can just print out the link to see how many listeners are listening to this event. So let's see what this returns. Okay, so over here, let's pick up some cheese and slice it. And if I look in the log, yep, there you go, 1. There's only 1 listener. Okay, that's correct. However, now if I go back into the main menu, and now I go back and I play again. Okay, so let's play. Let's just wait for the countdown. And once the countdown ends, pick up some cheese, go there, slice it, and there you go, there's the problem. Now we have 2 listeners. In this case, it doesn't really cause an error because the 2 listeners, they're just over here on the sound manager, so we are subscribing to this event, and we're doing the cut and playing the cut object. However, if here we do something with this transform, like for example, let's just do a debug.log on this transform.position. If we do this, here, let's go ahead on the first one, let's slice, and okay, that works. Let's go back into the main menu. Now play again, now wait for the timer, pick up some cheese, go there, slice, and if there you go, there we have our error. That is because we are now accessing the sound manager transform and that one has since been destroyed. So if you do use static events like this one here, if you do that, always remember you need to manually reset that state. It won't happen automatically on the scene load. And one way that I normally do it is just make a class responsible for doing that. So let's go ahead and let's create a brand new C# class. Let's call this the reset static data manager. And for this one, we want this one to run only on the main menu. That's only where we're going to reset things. So let's go inside the main menu scene. Let's go there. Let's create a brand new empty game object for the reset static data manager. Let's reset transform, just keep things clean. And let's attach that script. Again, it's very important that this object only exists on the main menu. Then over here, we're basically just going to go into any script and reset any data. So for that, on all those scripts, let's make a function. So over here on the cutting counter, let's make a public static function. Let's call this reset static data. And in order to reset any listeners, let's just go into the onAnyCut and set it to null. That will clear all the listeners. So we just do this, and then on this script, let's do a private void awake. And on awake, let's go into the cutting counter under the class, so not any instance. So we're going to access the static, and we're going to reset the static data. That will clear all the listeners on the cutting counter. All we need to do is make sure to do this on every single static event that we have. So on the sound manager, and by the way, here we can get rid of the testing code. Here we can see all of the static events that we're using. So we've got the cutting counter, then we've got the base counter and trash counter. So let's go here on the base counter and paste the exact same thing and reset this event, okay? And now let's go into the trash counter. So here on trash counter, same thing, reset this event, set them all into null. And by the way, here we have a warning. That's because trash counter extends base counter. So basically this is telling us that we are hiding another function with the exact same name. In this case, we do want to hide it. So let's actually make this new to make sure that this one is a different one, just to avoid that warning. And same thing over here on the cutting counter, we also need to make it new. Okay, so that's it. And now we just need to go over here onto the reset static data manager. Let's go into the base counter and reset the static data. Go into the trash counter and reset the static data. Okay, that should do it. Let's see. So here we are in the game. Let's pick it up and slice it. And yep, we've got just one listener. That's good. Let's go back outside, back into the main menu. Let's play once more. And over here, let's pick it up again, go there, drop it, and there you go, still just one listener, because we are now correctly eliminating all of the previous listeners. So this is the one sneaky issue that you must be careful with when it comes to object lifetime and statics. For static fields, you need to remember that they don't manually get cleaned up. That's up to you. So that's something you have to keep in mind, but you can also see how easy it is to solve. Now that this is solved, let's just go into the cutting counter and just get rid of our testing log. Alright, so with all of that, all of our scenes are working. So we can start from here from the main menu and go straight into the game. Then here we are in the game playing normally. We can pause the game at any point. From the pause screen we can either resume or we can go back into the main menu. And from back into the main menu we can once again play the game from scratch. And yep, there you go, everything works. Alright, awesome. Now the next thing that every game requires is some options, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to create a simple options menu where we can modify the audio levels. Okay, so here let's make the options menu. So on our game scene, let's go into the canvas and create a new empty game object. Let's make this the options UI. Let's stretch out this one to occupy the entire screen. Then inside, let's make a UI image. Once again, let's stretch out everything. Let's put this one in black in just almost full alpha. Okay. Now let's make some text. So let's create a brand new UI text. Call it the options text. Then for text, let's say just options. Let's put the width and height at 0. Let's disable wrapping, put it center down the middle, and put it quite a lot bigger. Okay, that's the options. Now just move it slightly upwards. All right. Now let's make some simple buttons to handle our audio controls. We're going to make it super simple, literally just a button we can click. So inside the options UI, let's create a brand new button. Call this the sound effects button. Then let's make the button a bit bigger, something like this. Okay. And inside for the text, let's say sound effects, and then we're going to have a number for the sound effects. Let's just quickly change the color. So put the text in white and the button over here, the button image, let's put it in a dark gray. Okay. Let's also make it just a tiny bit thinner, just like that. Okay. So this is the sound effects button. Now let's duplicate this one. This one is going to be the music button. So let's name this the music button. Then inside for the text, music, and then a number. And that's pretty much it. So by clicking on either of these buttons, we're going to increase and then loop the volume. So let's make a simple script to handle our options window. So in our scripts inside the UI, let's create a brand new C# script for the options UI. Let's go ahead and attach a script and open. So here, as usual, let's get some fields for our buttons. So a serialized field, private, of type button for the sound effects button. And then there's another one for the music button. Okay, both buttons. Now let's add the click event. So on private void awake, let's go into the sound effects button. And on the on click, let's add a listener. And we're going to do the same thing on the music button. Okay, so now when we click, we want to change the volume. So let's go here onto the sound manager and make a function to modify the volume. Let's make a private void change volume. And here we're going to increase the volume by 0.1%, so constantly increase in 10% increments. So that means we need to keep track of the volume. So up here, let's define a simple private float for the volume. Let's default it to 1F, okay. So now down here, we take the volume and we increase it by 0.1F. And now let's loop it back to 0. Now for looping, usually you do it using the modulo operator. So here you could do volume equals volume modulo of 1.1F. That way, when it gets to 1.1F, it would reset back to 0. But here, since we're working with floats, which can have a bit of odd precision, with this, let's just do a simple if to make sure that it always works. So if the volume is above 1F, if so, then let's just reset it to 0. Okay. So here we modified the volume, and let's just make sure to use it over here when we actually call the audio source.playClip at point. Here we've got a volume, but this is the one that we received as a parameter. So let's actually receive this one, rename this to volume multiplier. And we're going to basically multiply the one that we receive in the parameter by the one that we actually store. So this way on these functions, when we play a certain sound, we can still give an optional volume if we want to make it louder or quieter than the regular sound effects. Okay, so we have our change volume function. Now we just need to call this from the options UI, so that means this one actually needs to be public, okay? So now here on the options UI, we go into the sound manager, access the instance and call change volume. Okay, so that is going to change the volume. Then we just need to update the values on the options UI. So let's make a private void update visual. And this one we need to update the text. So up here, let's add once again some more serialized fields. So text mesh pro UGUI, one for the sound effects text and another one for the music text. Okay, we have both these. Then here the sound effects text.text equals, and we go into the sound manager, the instance. And then we need to get the volume. So over here on the sound manager, let's make a function to get it. So a public float return get volume, and we just return the volume. Okay. So then here let's get volume, except the volume is going to be a normalized value. So rather than showing 0.1, 0.2, 0.3 on the UI, let's just multiply the volume by 10f. That way we show between 1 and 10. Okay, then let's just round out this number and then add the text. So here's sound effects, and then we have the volume. Okay, so that's pretty much it. And up here, when we change the volume, let's just update the visual. And let's also make a private void start. And on start, let's also update the visual. Okay, that's it. Pretty simple. Now let's do the exact same thing on the music. Except on the music manager, we named it music manager, but over here we just have an audio source. There's no actual manager. So let's actually make one. Let's create a new C# script for the music manager. Let's go into the music manager object. Let's attach a script and let's open. So here we really just need pretty much exactly the same thing that we had. So let's just go here into the sound manager and just copy these. So on the music manager, let's paste them. We need a volume, so a private float for the volume, just like this. Okay, so that changes the volume. Except again, the music manager, this one, the music is constantly going to be on looping. So after we modify the volume, we need to update the actual audio source. So let's first begin by grabbing the audio source, and we just do a private void awake. And on awake, let's grab the audio source, get the component of type audio source. Okay, so we have this. And when we change the volume, let's go here and update this volume. Okay, that's it. And let's also default it to something like 0.3f. Okay, good. Then in order to be able to call this from the options UI, we just need to make it a singleton. So as usual, public static music manager for the instance. And we have a public get and a private set. And then an awake, just set instance equals this. Okay. So then here on the options UI, we can go into the music manager, the instance, and change the volume. And afterwards, let's update the visual. And down here on the update visual, let's do pretty much the same thing. So on the music text, modify the text to say music. Then we go into the music manager and get the volume. All right, that's it. All this should be working. Let's just drag our references. So back in the editor, let's drag first the button. So the sound effects button, that's this one. Then the music button, that's this one. Then we have the music text, that's this one. And the sound effects test like that. Okay, let's test. Okay, so here we are. The music is playing. And as I click, the music is currently getting louder and louder. And there you go, music is at max volume. And if I click again, now the music is completely muted. All right, awesome. And these sound effects also work. So like this, they should be less louder than usual. Okay, great. So everything works perfectly, except obviously we have one big issue. The options window is on top of everything. The goal is for the options window to be kind of a sub-menu of the pause window. We want to have an options button on the pause window that will bring up the options window. So let's do that. Let's first hide the options window. Let's go into the game pause UI. And over here we have these buttons. Let's just make one more. Let's put it down the middle. This is going to be the options button. And inside, let's modify the text to options. Okay. Now let's edit this script. So we're going to have another button. So this is the options button. And down here, we're going to have another click. So the options button. Okay. And when this happens, we want to just show the options window. So in order to access it, let's make this a singleton. So public static for the options UI. a static instance with a get and a private set. And on awake, as usual, instance equals this. So over here on the game pause UI, we go into the options UI, access the instance, and then call a show function. So we need to make this. So up here on the options UI, let's make those. So a public void show. And this one, as usual, just game object set active into true. And then we have a private void hide, and this set active into false. Okay, we have both these. On the other side, we show it. And over here on start, let's also hide it. Okay. Then let's also hide it manually. So let's add a button to close the options UI. So over here, let's show the options UI and let's make another button. Let's put it on the bottom. This one is the close button. And over here, let's just say close. So then here on the options UI, just make another button, the close button. And down here for the click event, we go into the close button and we just call hide. Okay, so that won't hide the window. However, remember that the pause window can also be closed by just pressing escape. If we resume with a hotkey, it will hide the pause window. So let's also make sure this one hides on the same thing. So we can do pretty much go into the kitchen game manager, the instance, and let's listen when the game is unpaused. So when that happens, let's hide this window. So once again, let's do things nice and clean. Let's rename this. So the kitchen game manager. And when this happens, let's just hide. Okay, this should work. Let's just drag all the references. So first here on the options UI, let's drag the close button. And then on the game pause UI, let's drag the options button. Okay, so let's test. And yep, right away the options window is not showing. That's great. And if I press an escape, there you go, there's the pause window. And if I click on options, yep, there's the options window. Now if I click on close, back here, back into resume, okay, works. Now if I pause, options, and now press on the escape key, and if there you go, it closes everything. All right, great. So everything is working fine. However, we have one slight issue. The option does work, so I can modify this to change the sound effects and music volume. So for example, let's mute the music and put the sound effects on 5. So I put it like this, but now if I stop playing and I hit play again and look in the options, and nope, there's the issue. Basically the data is back to the default. Obviously that is resetting since we didn't actually save anything, so let's save it. Now in Unity, the easiest way to save some data is using player prefs. So let's go over here on the sound manager, and when we modify the volume over here, when we do that, let's access the Unity player prefs, and over here we've got a bunch of set functions. So we can save a float, an int, or a string. This one, as you can see, takes a string and a value. So this is pretty much essentially just a dictionary. Now for the key, as you can see, it's a type string, but again, we should not be using strings directly. So let's go up here in order to make a proper constant. So a private const string, let's call it player prefs sound effects volume. And let's go sound effects volume. Okay, we have our nice certain constant, and down here, when we set the float, let's use this string and save the volume. Okay, so that is going to set the float. And now technically Unity is going to automatically save the player prefs. Basically there are only problems if Unity somehow crashes in between when you call set float and when it actually saves. But if you want to prevent that from happening, you can just go and tell it to save manually, just like that. That will definitely save it. And now we just need to handle loading. So up here on awake, when we have this, let's go into the player prefs and let's use get float. Let's pass in the same key. So this one takes a key and default value, so let's default it to 1F. Basically the default value is used if there's no saved data on this player prefs on this key. So the first time we run, it's actually going to use this default. And this one's going to return the saved value, so let's just set it on the volume. Okay, so that's it. That's all it takes to save some basic data. Now let's do the exact same thing on music. So over here on the music manager, let's first define our private const string for the player prefs music volume. And this is going to be the music volume. Okay, we have our string. And then down here, when you change the volume, player prefs. And let's set the float on this key. And let's pass in the music volume, okay? And then let's go into player prefs and actually save it. And now up here on awake, let's grab the volume. And it's going to be going to the player prefs in order to get the float on this key. And default value is 0.3f. However, over here on the music, again, we are not spawning the sound afterwards. The sound starts playing right away. So let's make sure to set the audio source volume to the one we grab from there. Okay, that's it. So like this, it should be working. So let's test. So here we are and the music is playing. Let's pause, go into the options. Let's bring the music completely down. So let's mute the music. Okay, the music is gone. And sound effects, let's put it on 5. Now let's stop playing and now play again. And going to the menu, options, and yep, there you go. The data was indeed saved and the music is indeed muted. All right, awesome. So here we have some basic data being saved. And also just a quick note related to saving. For this simple game, the sessions are pretty quick, so I didn't include any kind of save system for the actual game data. But if you want to know how to do that, I also have video covering that topic. Okay, so with that we have our options window working. The volume sliders work perfectly. The next thing we need to add to our options is some key rebinding. So let's do that in the next lecture.